So before we get into the new portion of our notes, I do want to go over this question right here. My projector is not quite in line, but it says, is this function continuous? Oh, it should be at x equals 0. I forgot to change that. Is this function continuous at x equals 0? This is a question that we have to answer. So before we get into how to do it, I want you to have a conversation at your table. What do we need to check to see if this is continuous at 0? 30 seconds. Okay. Think you have it figured out? Grace Farson, what did Pod 7 talk about?
I was still writing the problem.
Okay. Did you guys talk about anything?
Well, I was just thinking like when we have polynomials, they're continuous, but we have to make sure that they meet at the same spot. And -10 like would fill a hole if there was a hole there, so we need to check to see where the hole is and if the top and the bottom functions meet.
Okay, so we need to see if the functions meet and if the -10 fills in a hole. Okay. How could we maybe reword Turner's explanation to use some calculus terms? What calculus things do we need to look at in order to do what Turner just described? Okay, Eli, what calculus words do we need to use? Which limit do we need to be worried about?
The left and the right one, you gotta make sure that it's
At 0. Okay. Does that sound reasonable? Okay. Has everyone had a chance to write this down? Who needs more time to write it down? Okay, I'm going to give you some time to write it down. Sorry, sometimes I get really excited and I forget that. Sorry.
Oh, versus full schedule.
Oh, don't read
It's
the
not
beginning.
continuous because the dot.
This is 1, 2.
Okay. Okay, anyone need more time? So let's look at the limit. The limit, as x approaches 0 from the left, would be which piece would we be worried about? 1, 2, or 3? Piece 1. So we're going to plug 0 into piece number 1. What do we get? -1. Okay. The limit, as x approaches 0 from the right, we would plug 0 into which piece? Piece number 3, the bottom one, where x is greater than 0. That's from the right. So we have 0 squared minus 4 times 0 minus 1. What do we get? Oh, that's good. Okay, so this tells us that the limit as x approaches 0 of this function is -1. So that's a start. I think that's our second stipulation. The limit must exist. The first stipulation is that the function value exists. All right, well, our function value at 0, it says, is -10. So the limit exists, the function value exists, however, they're not the same. F of 0 does not equal the limit as x approaches 0. Oh, that's a G. Sorry. Okay, so we are not continuous. And I would expect to see all of the work. At least you identify what the limit is and compare the limit to the function value. Okay, since the limit equals the function value, it is continuous. Since the limit doesn't equal the function value, it's not continuous. Sorry, Jesse. There you go. If your limit doesn't exist, then bam, it's not continuous. Okay, so what's happening in this picture? The limit exists, so we have basically two functions meeting at a hole, but that hole's not getting filled in. Okay? All right. I'm going to pass out a piece of paper that you and your group are going to work on for like the next 10 minutes. Okay? Before I tell you what the intermediate value theorem is, I want you to think about something. It probably will take less than 10. We had at 43 today. Okay. Why not? Tell me something. It's obvious. It could be obvious. Are you talking about? So where are your points? Okay. So they're like on opposite sides of the axis.
Yeah.
Okay, because your function is continuous, right? I mean, like, it's obvious. Also, your points are on opposite sides. Oh, yeah. I thought it was
It goes up 3.
Oh.
Because the reason yeah, we don't know what happens.
It has to
It'll be higher. It'll be at some point.
Because 5 is.
So
Oh,
which
yeah, so it would be like, or negative.
Yeah.
will it though? If it goes,
That's the.
I'm asking what
I
height
got
are you in?
that.
I think that's one possibility, but does it? Could it turn around?
Yeah, but ours.
Right? Okay, so are you?
Prop.
Prop.
Well, that's basically just two.
That's by 3. The height is 3 and right. So what I want you to do is don't worry about 5 and 6. Worry about 1 through 4 and 7. Okay? Worry about 1 through 4 and 7.
All of those y values are included between the 2 points.
One through 4 and 7. One real life Give a real example.
It's a line of expression.
You're supposed to skip 5 and 6,
Oh.
But what about
No. What's the?
Give you about 1 more minute.
We don't know real life.
Okay, so what
or could we
What's
get
happening?
an asymptote?
yeah. So like if you wanna walk, you wanna get into
So 2 and negative 1 are equal.
So is there anything like in line where
Or windows.
What's one
something's
is like
here, something's here, on your way there, you're gonna have to hit what's in between.
Stairs.
Okay, so at your pots, determine who lives the furthest from the school. Who has the longest commute to school? Alright, whoever lives the furthest away, you are the speaker for your pot. Okay? So, whoever lives the furthest is the speaker from your pot. So, pot number 8. Here I have some examples of things you could have drawn. What must occur between 1 and 5?
C, the x-intercept.
Okay, so pod 8 says C, x-intercept. Pod 2, y.
Because it crosses the x-axis.
Okay, and why do we know it's going to cross the x-axis? Like, how do we know that?
Different quadrants.
Okay, so we're on opposite sides of the x-axis, right? Different quadrants, that's what you are telling me. And we have, what kind of a function? The third word in number 1. Consider a continuous function, right? Okay, so we're on opposite sides of the x-axis. We're a continuous function. It's got to hit that x-axis. Okay? Pod, what are you, 5? Are you 5? Pod 5. Which of the following heights is the function guaranteed to reach? Why?
bisect because the line that I drew, like it passes into a point.
Okay. So your graph went through it, and that's what you looked at. Okay, pod 4, anything to add to that? Why do we have to hit those 2 points?
The 2 guaranteed points that they gave you, the -1 and 2 are in between those y coordinates.
Okay, so we have like 2 coordinates. Here we have a y coordinate, here we have a y coordinate. All of the y's in between, you're saying we would hit. That, ladies and gentlemen, is the intermediate value theorem. And I'll even make it nice and simple for you. Okay? If a function is continuous between a and b, then it takes on every value between f of a and f of b. If we have a continuous function, then whatever the height is at a and whatever the height is at b, we have to hit every height in between. So this would be something for your notes up here. I'm going to get to question 7. You just wait. Did someone say I'm confused?
Grace did.
Grace. Okay. Here, what was this called? I just turned my page. 1, -4. And this guy up here was 5, 3. So essentially, in between x is 1 and x is 5, we are going to have all of the y values in between -4 and 3. We're going to have to connect those dots with a continuous function. So when we connect the dots without lifting our pencil, all of those y values in between -4 and 3 will be somewhere on our graph. Does that make sense?
Yeah.
Okay. Pod 1, what would be a real life example of that happening? Oh, I've already asked you. I'm sorry. Didn't I? No. Okay, then go for it. I'm trying to be like random.
There's certain things you have to pass, like maybe you have to like pass through a parking lot to get to like the destination, things like that.
Okay. Okay, so you're thinking like locations. Okay, great. Another real life example, pod 7.
What?
Let's go.
Grace said floating down a river.
Okay, I like it. I like it. Here's what I like to think about. At some point in your life, you were 2 feet tall, right? And now, like, I'm 5'2". At some point, I was 3 foot tall. I don't know when, but at some point I was, right? Okay, and so were all of you. Okay. Do we have this written down?
Yes.
Okay. Write down this right here. Write down this right here.
Some of our freshmen don't seem to be 3 feet tall, so
Oh, I think.
some of them are.
The older you get, the smaller freshmen. But they're still all the same. You just keep that time.
No,
No, it's
the
not.
grades are definitely getting significantly smaller
No.
every year.
I swear, it looks like there's
When your class started, I even remember specifically.
Somebody asked me if I was a senior while I was a freshman.
If you have not
I don't
done
know.
I think I've recommended.
Okay, so we are done writing this down. You know what? People tell me that I look like I'm a teenager still, and I am in my 30s. So it is okay to look young. Not a problem.
Thank you.
I got respect because I was
My first year of teaching, my assistant principal asked me for my hall pass. I wasn't teaching here. And I was like, I work for you. It was extremely awkward. Okay, so basically, in this example here that I have, I didn't have you to write this up here, but verify that the intermediate value theorem applies on the interval and find the value of C that is guaranteed by the theorem. So I've given you an interval. This is an X. This is a domain interval. What should we probably know about our X's? Okay, we've been talking about heights, right? Anytime you have the intermediate value theorem, we need to determine heights. So we need to figure out what f of 0 is and what f of 5 is. If you sit in an odd pod, we all know what f of 0 is. It's the constant 4, right? F of 5, take a moment and plug 5 in mentally. Okay. Adam, what is it? 24?
You know it's better than 24.
That's a classic.
Okay.
Wait that.
So, okay. What do I want to say? Okay, so is 10 in between those two?
Yes.
Yes.
Okay. F of C is in between 24 and 4, so we know that there is a C value. Okay. So we can actually find it. So we're going to set our function equal to 10, which means x squared minus x minus 6 equals 10.
Wait,
What?
you mean x squared minus x equals 6?
That's right.
Equals 0. I moved the 10 and wrote 10. Sorry.
For the inequality, shouldn't it be 0 to 5?
Well, I'm talking about f of c, so I'm talking about the
Oh,
height.
Yeah, got it.
Okay? Eli, unacceptable. No. Eli, what is this factor to?
X minus 3x plus 2.
So this happens at 3 and negative 2. So both of them are my answers? I heard like lots of no's. Okay. Andre, you shook your head no. Why?
But only one of them will equal 10. You plugged in.
So this would be 9 minus 3 plus 4. That's 10. This would be 4 plus 2 plus 4. That's 10. Okay. So let's think of a different reason.
Oh, wait.
Aaron.
Because -2 is outside of the domain.
Ah, okay. Negative 2 is not in the interval that we first discussed, right? Our interval is 0 to 5. So I don't really care about negative 2. Okay, so C would equal 3. Does that make sense?
Yeah.
Now, we're not going to do this example, but I just want to kind of preview it. Here, you're going to get a question in your homework that asks you, prove that there is a 0 on the interval. You're doing the exact same thing, but what would you hope to find in your y value? On your interval, your y values would need to be one above and one below, and so that way they would go through the x-axis, right? You would need one value, y value above the x-axis, one value below the x-axis, so then you would have a 0 in between. Those are the x values. So like f of -2 and f of 1 one would need to be positive, one would need to be negative,
Let's go, Chris.
so that we could pass through zero. Okay,
Like, are you kidding?
It's fine.